So let's talk about integers, floating points, and decimal places. Now, JavaScript, as well as many other languages such as Python, Ruby, and Java, all use this same floating point system. Now, all JavaScript numbers conform to the IEEE 7.4 specification of floating point numbers. So what does this mean? Now, it can be quite interesting when you get started first off with JavaScript, when we dive into something extremely simple. Now, we know that we can create numbers such as 99, and this is what we know as a number literal. Now, JavaScript numbers also support decimal places, so we could in fact say 99.99, and it's completely up to you. You can create any kind of number that you like. Now, the interesting thing occurs when we do something simple such as 0.1 plus 0.2. Now, if you type this into a calculator, you would expect it to give us 0.3 exactly. Now, because this is an expression, we can save this out and hopefully we'll see the word true. However, that's completely not the case. So why doesn't 0.1 plus 0.2 equal 0.3 in JavaScript? Now, again, this is not JavaScript specific. This is how floating point numbers work due to their binary nature of their encoding. Now, we could spend an entire day diving down into binary numbers and how JavaScript numbers really work. However, the long story short is simple mathematics such as 0.1 plus 0.2 give us something in the console that looks a little bit like this. So why do we have 0.3 and all these zeros and finally a 4? Now, this is how computers add numbers together. When we buy something from a store, we could have a constant which has a price, and for this we'll assign it a decimal place of 9.33. Now let's assume that we wanted to buy 3 of these items. We can say that we want the quantity to be 3. Now we would get to a checkout perhaps at the store, and something like this would happen in the machine. We would have the price multiplied by the quantity, and that then gives us the price of the final price. Now, when we get to the checkout, we may not have 27.9000 and on, followed by a 2. That kind of currency doesn't make sense and it doesn't exist. So it's a good thing to know that how JavaScript floating points work and why this behavior happens. Now, similarly, if we tried to do something like this, where we had 100 divided by 3, we get 3.3 recurring until we reach a 6 at the end. Now, the same rounding thing happens. So let's assume that we have this number here. And what we're going to do, instead of dividing it by 3, we're going to times it by 3. In the same way that multiplying 33.3 with the 6 at the end does in fact equal 100, when if you typed this into a calculator, it probably wouldn't give us the same result. Now, if we got rid of this 6 and added some more 3s, for example, that also creates 100. Now, this can be quite confusing, and it's due to the way that JavaScript numbers, in fact, work, which leads us to more of a solution. So we'll save this out. We'll have a look at what we got on the right. We have 27.99, and this could be dollars, pounds, and so forth. Now, what we ideally want to do is do safe multiplication. Now, what we could do is, in fact, trim our resulting value, and we could just take those 2 decimal places. But you can imagine in very sensitive things such as banking systems with bank accounts, we don't want to just guess that the number happens to round up correctly and then implement something incorrectly. So what we can do, and we'll say another price, we'll start with our 9.33, and we'll also create our another quantity. Now, this is just going to be similar to the above. However, we're going to have one subtle difference, which is going to save the day for us. So here we'll have our another price, and we'll just multiply that by our another quantity. Now, we'll save this out, and we'll see the exact same thing. So what is the solution to dealing with, for instance, numbers that are currencies? We would like to make some safe multiplication and get all the rounding and everything done for us. Now, there's a couple of ways that we could do this. We could write scripts which trim the number to decimal places, but it's not accurate. So a more accurate way to do this would in fact be to remove the decimal places. And we can do this by timesing it by 100. So let's times it by 100 and we'll see 2799. So The interesting thing and the key thing to remember in this video is that when we deal with integers, which are the whole numbers here, we can perform blazingly fast and super accurate mathematic equations such as multiplication or addition and so forth. So what then happens when we want to have our another price? All we would need to do here is divide it by 100, and you can see that we have 27.99. So when we get to checkout, we're not greeted with please pay us 27.99.00 and on, and then number 2, we're greeted with this 27.99 as you'd expect when you go to a checkout. So that's a brief overview of dealing with decimal places and floating point numbers with JavaScript. In the next few videos, we'll cover this in a little bit more detail just to understand how to parse numbers from floats and integers. But for now, we've had a nice introduction to JavaScript numbers using decimals and a nice trick to just multiply something by 100, get rid of those decimal places, perform some logic operation, and then simply divide the result again so we don't end up with any rounding errors that may be present.